Hello, everyone. Hi, Jesus. How you doing?
Hi Max, how are you? Can you
I'm
hear me
very
all
good,
right?
thank you. Sorry, what?
I was wondering if you could hear me all right, because I'm
Yeah, yeah. You can hear me.
yeah,
Everything's good.
all good, perfect.
Perfect. All right. I'm jumping in this week for Alexander. I bet you guys haven't seen me before, but I'm Max Anderson. I'm a part of the Neo4j developer relations team, and I also work with Alexander on numerous other things. And what about you, JB? You and I haven't had anything like this before, right?
That's true. Yeah. Yeah. I'm part of the field team, and yeah. I guess you and I have been interacting a bit in the specifically. I mean, some on a topic that we touch very often on these series, which is the Neo Semantics plugin, because you've been helping with
Yeah,
the
right.
release lately. So but it's true that we hadn't had the opportunity to have a well, I was going to say face to face session, nearly face to face, but so yeah,
Well,
no, that's good.
our faces and other faces.
Exactly. But as it happens, I'm in your place because I'm in the Stockholm office today because as you know we're
Oh,
hosting
right, right. Well, I could
we're
have been
hosting
there today as well, but I was
no, it's
prepping another talk
all
today, so I
good,
felt it was good to be home.
all
But
good, all good.
yeah, so before we get started, today's topic was RDF integration patterns, right?
That's right. That's correct.
All right, awesome. Well, I'm not that familiar with RDF. I do know what it is. I did a little bit of work on like the semantic web and like so
Mhm.
like the terms and such shouldn't be too like strange to me, but I haven't really worked with it. So I think it's perfect for this type of scenario as well. And I'm really interested to see what kind of things we can come up with. Uh, I should also mention that. The nodes 2022 things are online. So if you go to neo4j.com/nodes 2022, you can sign up there to be a part of the developer conference that will be coming down the line as well. And you did the Graph Summit thing today, right?
That's correct. Yeah, we were hosting it here in well, as you know, we've done a number of cities over Europe and in APAC, and today was Stockholm, and
All right.
in a couple of days on Thursday we're doing it in Copenhagen. So that was
All
the
right, all right. So if
visit.
you guys are in Copenhagen, you should sign up. I think there's a meetup page for it that you can just Google and you'll find it.
That's
There's
right.
also a Graph Summit page on
Exactly. If
neo4j.com.
you go
Yeah,
Neo4j Graph Summit, you should be going straight to the home page, and you should see. I mean, I was going to say all the dates. Copenhagen
hmm
is the last
yeah,
one. So you should see all the places where we've been, but the one left is Thursday. Yeah.
perfect. All right. So what's the first topic we're going to talk about today?
Yeah, well, I was going to say that it's great that you're just somehow familiar, but not very familiar with RDF, because the idea is to do it. I mean, assume no previous knowledge, right? So and the way, like as we were discussing before, the way that's the way I play with Alex normally. So he listens to that, and whenever there's something that he doesn't get or is unclear, he will just throw in a question, or if there's something coming from the attendees. But yeah, the idea today, and again, we're kind of listening to our audience in a way, because one of the questions that we got in the feedback on the recordings in YouTube was that they wanted to look at how do we get RDF data, for example, from DBpedia, from Wikidata, one of these public large data sets, but kind of going into the detail on how we do that, because it's true that in some sessions up till here we've kind of just step over that, saying, well, we assume that you know how to get RDF data in NFJ, and we probably haven't done it within our level of detail. So today the plan is to cover, you know I've called it like integration patterns, but what I mean is, what are the different ways in which we can use RDF, available sources of RDF, RDF generated out of Neo4j to
All right.
integrate, to move data around, because ultimately that's what RDF is, right? Is a model for data exchange that can be serialized in a number of different ways, and that's the idea, and for
So
that,
So what I remember from my time doing with all this,
Yeah,
that you use some kind of query language called Sparkle, right, or
correct.
Gimlet, something like that. Is that correct?
That's absolutely right. So it's, I mean, Sparkle is the standard query language for RDF. Not
Hmm.
always will we have queryable endpoints, and that's exactly the kind of thing that we're going to kind of cover today, which are the many ways in which we can have access to RDF data. Sometimes, like you say, there will be a Sparkle endpoint that we will be able to query, and that will give us a lot more flexibility and a lot more granularity. But sometimes
Yeah.
we just have a file or a fragment or even an export or a dump in RDF that we just can.
All right.
So that's exactly the plan for today's session. Try to cover most of those options, alternatives, and ideally, if we have the time, do a bit of hands-on as usual, and show step by step how to deal with each one of these situations. Does that make sense?
Yep. Yep. Perfect.
Fantastic. Okay, and hi everyone, all the people that are saying hi on the chat. That's really really nice, and even people we met in Melbourne. That's another of the graph summits that we did. It's great to see you again, meeting us at this going meta series. So fantastic to have you with us today. So okay, let me share my screen. I mean, I'm on a single laptop today. I mean, a single screen. So I don't know how this is gonna turn up. Let me know when you can see it. So I think I'm sharing it already. So I should put. Can you
Give me
see
one
my?
second. There we go.
You should see a slide. I mean, my plan is to have a brief introduction and then quickly going hands on with Neo4j, right? So. Good. So I don't know if I'll go on. Is this readable okay, or should I go on full screen? Because it gives me can probably
I
go.
think full screen is better, at least. If
Good.
that.
Let's
All
go with
right.
that.
Perfect.
Cool. So let's start with again a simple starting point, right? So we're all familiar with the many ways in which data can exist, right? So we're of course super familiar with tabular data. I mean, we've all worked with Excel style data, right? CSV files,
Yep.
relational data. So when data is presented in tables and rows and columns, natural ways of exporting, exchanging it is probably CSV files. I mean, it's not kind of an official standard because we know how painful it can be sometimes to deal with kind of cases like the quotes, escaping, and all that. But CSV is a format for data exchange, if you want, of
The best
tabular data.
thing is everybody knows how to handle CSV, right?
Exactly. So there's things like JSON lines, as we're going to see in the next section. JSON, like XML, are actually hierarchical data models. So you can represent kind of you have a root element, and you can have child elements, and basically that forms a tree. But there's this variant of JSON called JSON lines that it's a convenient way. It's kind of a more kind of better structured way of dealing with tabular data as well. But just as an example, and you can of course, why not use JSON or XML? It would be kind of a bit of a I mean, not an overkill, I would say, but you can express a lot more than just rows and fields with JSON and XML. But why not? You could eventually serialize tabular data as well with JSON and XML. But tabular, one case, hierarchical data for which we have JSON and XML, and then we have linked data, RDF data, right, which is kind of triple-based data, statements. And that's the kind of thing that we serialize. That's a model, again, for data exchange. That's what RDF is. It's a triple-based model for data exchange in the web, as it was defined. And it has a number of serialization formats. I mean, you can serialize RDF using XML, using JSON, Turtle is meant to be a more kind of human readable, and triples is literally an enumeration of the triples. So different.
RDF is not really a data format. It's more like
It's a
what's
model.
inside it. It's about the semantics of what's inside.
That's right. I mean, and you can layer things there, because then on top of RDF, there's vocabularies like OWL, like RDFS, where you can define ontologies. But at the core, RDF is just this model where we identify things with URIs, and we represent the world in terms of triples, which are statements, subject, predicate, object. That's it. That's RDF. So
All right.
depending on what your preferred serialization format is, you can exchange data, RDF data, in many formats, many serialization formats, and I've mentioned some of those there. So
How,
that's the
how,
starting point.
how does this connect with like things like schema and ontologies and stuff like that?
Yeah, well, it does. I mean, the thing is, every triple, if you want, is a statement, right? Where you
Right.
have something like, I mean, let's think of a simple example, right? Max is, I mean, let's think we have a URI that identifies you, and a URI that identifies me. Let's think our pages or our Wikidata IDs, whatever. And there's a connection that a triple that states that Max knows Jesus, right? So this knows or is friend of or works with. So this kind of statement would be described in terms of a vocabulary. So you have to use a URI. And for that, you use defined vocabularies, which we're going to call ontologies. So that's every statement, everything that you state in RDF has to be defined using URIs and therefore describe it in models or schemas that we call ontologies. Does that kind of help?
Yeah, I got it. I got it.
Brilliant. Perfect. So that's where we are. So that's the kind of it's we can think of it in simple terms as a way of exchanging graph data in many different serializations. And we're going to see that of course there's a lot of RDF sources of RDF. RDF data is available in many forms, and I mean, I'm not trying to classify it, but I've defined like two ends of the spectrum. So I try to define how do we access the data, what's the dynamic nature, whether it's static, changing, dynamic, no, and what's the size. I mean, and I know this is a very vague definition, but at one end of the spectrum, we have big RDF dumps, right? So it's a data set or an ontology or yeah, a set of triples that's published as a data dump in a way. And typically I mean, it doesn't offer any kind of query interface, any API. It's just a file that probably will be zipped and you can download. It's static data and it's rather typically large data sets, right? We're going to go actually, before I move on to the next ones, let me look at some examples of that. So
Right.
you see there, and that's something that we touched on I think it was episode 1 of this series. So to the left, you have the British Library catalog. So the British Library catalog, I don't know if it's readable, but here's the URI, which I'll share at the end of the session. You can go there and you see that they make the catalog available in a number of formats. And one of them is actually, we might want to go and have a look because, that will
Yeah,
make
that
it.
was pretty small on the screen. Perhaps it's better.
Exactly. Let me just copy that and we can go there. So that's is it readable? I can make it a bit bigger. But you see that there's a free download of the whole collection, and that's the catalog, the bibliography, all the books and publications, and it's published in a number of formats. So in particular in RDF, in three of the serializations. So there's N triples, there's RDF XML, and there's Turtle. So there's three flavors of it that you can download. And like I mentioned before, this is typically a large file that's static. It's just an export. Maybe they update it regularly or every year or whatever. And that's the kind of thing that you download from some location and then you work with. They happen to also present it in other formats. They also publish it as CSV, right? So you can also export it as tabular data. But for today's session, that would be one example, right?
Yeah.
What else? I mean, there's many others, and I thought I'd mention just a couple of them here. But another interesting one that I've worked with in the past is the for people who are working with the WordNet data set. There's a version serializes RDF that's published annually. As you can see, there's a 2019 edition, but it's another static data set that we can download and work with. And there's many more.
Are these data sets like self-contained, or are they like interconnected with other type of data sets?
In some cases, you will have a connection to external resources. So, for example, here in the British Library, I know that when you have a book, you will have all the information about the book, the author, the publisher, the ISBN number. But sometimes, for example, they link it to the how the I'm not an expert in this domain, but I think there's a classification system created by the Library of the Congress in the US. So there's a
Okay.
Library of the Congress ID. So in these books, you have a reference to that code. So it's in a way a pointer to an external resource. So that sometimes you have these sort of references. I don't think that's the case in WordNet, because that's purely a lexical database. But it can be, and again in the mesh dataset, which, as you can, I don't know if it's readable here, but it's the medical subject headings, which is a hierarchy of terminology of biomedical terms. Again, it's published by the National Library of Medicine, and it's exposed as RDF format, and also as XML and some others ASCII format. But again, these are some examples of data dumps that commonly, how would you use this type of, and we'll get to that in a minute, but how would you use those? But maybe there will be data sets that you want to import into your data store, and do a massive batch import and then work with it. And that's exactly what we did in episode 1, I believe it was. So we took the dump from the British Library. We loaded it in Neo4j, and what we did is and I refer you all to that. I mean, I think we have a pointer later on, but what we did is we run side-by-side queries on Sparkle on the data catalog on the British Library, and then at the same time we were running the equivalent query in Neo4j in Cypher, and seeing how the results were identical. So that was one example, one exercise. And what we did was take this dump and just import it into Neo4j. That's typically a batch process, and that's one way in which you would use this type of data sets. Does that make sense?
Perfect.
Good. So let's go to the other end of the spectrum, and let's keep the bit in the middle. So once you have a massive batch export that's static, and at the other end you have an API-based access to an RDF dataset that will, in many occasions, would be Sparkle-based, because Sparkle is a structured query language that's based on triples. It's the standard query language for RDF. So if you have a Sparkle endpoint, you will be able to query the dataset and select what you want to extract from it. So you don't need to process the whole file or ingest the whole file. You can say, I want to run this query and process consume whatever this query returns. Now, Sparkle has a number of flavors, and we'll touch on them in a minute. So you can run select queries, construct queries, describe queries, but it's a proper query language. So it gives you, I would say, the highest level of granularity and of precision in terms of how you can consume the RDF in a dataset, right? Now, there's another variant of that, a probably simpler one, and it's based on this idea. I mean, RDF is the kind of the foundation of that vision of the semantic web, right? So as I was mentioning before, RDF is a model for data exchange in the web. So the things that we describe with RDF are described with URIs. And the idea that one of the principles of linked data is that these URIs should be dereferentiable. So if I put this URI in my browser, that should give me some information that's informative about what this thing is, right? And that will return some, essentially all we know about this resource. I mentioned before,
So
imagine
preferably all of these URIs should be immutable and never change, basically.
Exactly, because that helps you then linking, right? That's the idea of the semantic web. If we have a URI that identifies Max, I have stated that Max is friends with Jesus, but maybe we'll want to state on a different location, and that's the idea of the web, distributedly owned data. I'm going to state that Max works at Neo4j, but I would like to use the same URI, because if I use the same URI, the things will link together naturally. And I would say, I know about Max, that he works for Neo4j, and he's also friends with Jesus, right?
And then you can take the properties from one data set and the other data set and say, this is the same person, and this is what we know about him, right?
So that's the ideal world scenario. So if we all talk the same language, if we all identify things with the same IDs, then integration becomes trivial and very nice, because you just have to bring data together and it will link nicely. Unfortunately, it's not always the case, right? And you might find an ID for Max in one system that's not exactly the same that we use in another system, and we'll see a lot of that, in very often, right? So the IDs that Wikidata use are not the same that DBpedia use, and like this, you can go on and on. So Of course, data integration is not a solved problem. Will never be, I think. But
Right.
it's true that the use of unified and consistent URIs would be a good step in the right direction. So yeah, let's look at some examples of that, like we saw with the other one. So these are API based access points, and like I mentioned, well, DBpedia is one of them. So if we have a URI that identifies, for example, Neo4j, let me
Mhm.
again show it live because it's going to be probably better readable. So let's say I have these. Actually, I don't need to. I can do something like DBpedia Neo4j. So if I type that, probably I'll get the first hit. So there you go. So we have a page that describes Neo4j in DBpedia, right? So and you see that it offers me a number of serialization formats. So these, by default, what I get is kind of the human readable version, like the HTML base, something that looks like a table and that I can have a look at and as a human
But,
interact with.
but it's always the same data. Doesn't matter which format you're using, right?
Exactly. So it's presented in a nice way here for humans, but normally, and that's the whole idea of RDF, what you want to do is to enable interoperability, to enable programmatic use. So that's
Right.
kind of more, I mean, still readable. So if I go to the turtle format, probably you can read the triples here, right? So here we're saying what, like Neo4j is a database management system according to Wikicata, which may
Right.
be one categorization type. It's
This might be
also
much more easier for a computer to read, for example, right?
exactly. So Neo4j has a label. A label is like I mean, that's a bit confusing because in our world, a label is a different thing. A label in a property graph is kind of a type, but a label, let's think of it as a name, as a string that describes the resource. So Neo4j, I mean, in RDF we can have language tags, but Neo4j is the same in English, in Korean, in French, in Italian. I mean, this is convenient if you're describing a term that's spelled differently in different languages, but with
But you
Neo4j.
can do that in Neo4j as well, right? I mean, like you usually use them to describe a category, but there's nothing limiting you from actually attaching more labels and stuff like that as well.
Absolutely. And you see here we're saying that there's a comment that describes Neo4j, and this is probably an image, or I don't know what that is. But this is kind of a machine consumable data. It's structured
Right.
and I parse that's RDF in turtle format. That's a TTL. So it's one of the serialization formats. But there's many others, like we saw before. So this is one example. And what I'm doing here is I'm dereferencing a URI. So I take an identifier and I don't know. We can try, for example, but let's say, can we try to find something here? So you see that there's a link to the Cypher query language here, right? So
It's
it's
really small, but yeah.
yeah, that's probably
True.
not very readable. We can make it a bit bigger. There you go.
Oh, there we
So
go.
for example, we're saying that it's connected to software companies of Sweden, right? So there's a number of things. So each one of those, if I took it, I mean, that should give me. So for example, it's connected to the Java programming language. So if I take this
Right.
URI, hopefully that should give me
Should tell you what Java
similar
is.
page that describes the Java programming language. So that's how it's linked data. So this is another resource that I can also serialize as RDF in any of the different available. I use Turtle because it's typically
So
the
we have a question here from one of the users
Sure.
that says, "Can the URIs can the URIs be defined from relational databases? Is there such a tool for MongoDB?"
Absolutely. Yeah, and that's a very, very good point because you probably have noticed by now that RDF is kind of the vehicle, is how we exchange the data. But
Mhm.
where is it persisted? It can be anywhere, and absolutely, you can have RDF. You can have data living in a relational database, and you can generate out RDF out of it. It's very similar to what we do at Neo4j. Neo4j is a property graph, but we can expose a property graph as RDF and in the same way import. So
But you
the
would
answer,
have to put some kind of plugin or some kind of
yeah,
middle
exactly. So
thing to
correct,
take it out of your database and kind of serve it to whatever you want
correct.
to go.
And that's what semantics helps us with. So that's exactly right.
Right.
And similar with a relational database, there's a number of libraries out there that do this mapping. So you can say, take this table maybe select these 3 columns and use column 1 to generate the URI. Maybe, yes, absolutely, you can synthetically generate it. I mean, it's like you were saying before, Max. I mean, it's convenient to have standard URIs. So if you refer to things like a country, like a company, yeah, maybe you want to use standard ones. But let's say you have something that's local to your organization. So you have an enterprise data. So you're free to create your own URIs. The URIs are unique identifiers that we use to link data together. So the answer is yes, you would generate it dynamically from your relational database. The only kind of constraint is that you have to keep in mind that that's sort of a primary key. That's something that's used to uniquely identify resources, and therefore we can integrate database.
If a resource or some kind of representation changes over time, how would you keep track of kind of the version?
Ideally, what changes is the state, not the unique identifier. So what would make a life easier is, I mean, let's say in the future, you and I live Neo4j and still identify, because as a person, you don't change. So it's still me, but now my status of my works for would not be Neo4j, but whoever my next employer would be, right? So you would have additional triples, and then it becomes a modeling problem, because you probably want to, instead of saying works for, you probably will want to have a has employment, and then the employment has a start and end date. But ideally,
they would try to preserve the URI that describes the person, but maybe serve it up as a new version of the same document or something like that.
Exactly. If that's possible, then that would make data consumption a lot easier. But then, of course, it's not always the case, right? And you will have to say, hey, this URI that used to represent Max, well, there's now this other one, so you have to link them with some kind of history, like this resource previously known as this one. For example, I mean, you'll have to create some kind of...
There's no like standard way to manage temporal models.
No. It's entirely a modeling decision. So you will have to come up with... I mean, maybe there are ontologies out there. There's some vocabularies, but it will be up to you to either use an existing one or create your own. I mean, in the end, RDF is just the framework to represent data as triple and with URIs. What vocabularies do you use is entirely your choice. And how do you express the fact that this resource is the same as this one, except that it has evolved over time? You would have to come up with a relationship that describes that.
You could find an ontology that has some kind of versioning in it, and you could find an ontology that has temporal dimensions and stuff like that as well.
And I'm sure that exists. I mean, I'm of course I don't know all the ontology in the world, but I'm sure there's some kind of versioning ontology out there, and something that we could use for that.
I've seen there's a lot of those ontologies out there.
Exactly. So yeah, so if in these cases, you see, all we need is a URI of something, because if the service, like the DBpedia in this case, is capable of return some structured data, RDF data, just from an HTTP request on a URI, then that's very simple, because all I have to do is send that URI and then consume the RDF that returns. So yeah, that's the first option. But then if we move to the right, we have the one that we described before, the richer version of it, which is when we have a proper query endpoint. I mean, it's not always the case that you want to offer a query interface to your data, but it is in some public data sets like DBpedia, Wikidata, or like Mesh in this case. And this is just a query interface where you can, and we're going to use this. So let me also bring that, because that's going to be useful for the second part of the session. So we can go to this page, and that's a Sparkle endpoint. So here I can type any random Sparkle, and I can execute the query, and that will return the results. And we're going to see in a minute how to consume that, because interestingly, I mean, this, and of course, this is not going to be a Sparkle tutorial. I'm going to make it a bit bigger so that it's more readable. But you see that what we're doing here, I mean, the one that comes by default is there are this A is a shorthand for RDF, right?
Okay, all right.
So what
So
we're
are you
saying.
using a lot of those shorthand? What is the question mark concept? Is that a variable
Yeah,
or
the
something?
question mark indicates variable, so it's so we
Okay.
can call it x. So that indicates that whatever comes after that is an alias, is a variable in my query.
All right.
So yeah, that's my Grammarly being a bit silly. I don't need Grammarly on my queries, so I don't want it in dbpedia. That's good for text, but not for Sparkle. So yeah, what I'm doing here is a select query where I'm saying, okay, there will be triples of type that is a triple, right? So there will be a, or let's call it subject, the predicate is type, and the object, let's call it object, subject, predicate, object. So that's a type
Right.
statement. So I'm saying this thing is of type X, Y, or Z. So what I'm wanting to get is give me those types, right? So whatever's on the object side, keep that as and do a distinct on it and
So
limit it
you're
to 100.
asking for 100 types, basically.
Exactly. Give me the first 100 types that you can find. And as you can see, interestingly, that returns a table, right? So it's tabular data. And we're going to get to that in a minute because interestingly, we're querying an RDF dataset with Sparkle and we're getting a tabular structure as a result. And that's perfectly natural. Select queries, and we're going to see that in a
Right.
minute on the slide, do return a tabular structure, a set of variable bindings, right? So if we wanted to get the subject as well, subject and object, we would get two columns, the subject and the object. So we see that we get records, basically. We get matches from that query. But let's stop it here. So we can use the full power of Sparkle here to explore the dbpedia dataset and return the data that we want. Okay.
Right.
So this is the kind of the rich and same for mesh, right? I'm not going to show, but it's exactly the same. So it's kind of the more granular end of the spectrum. So we can be very precise and be specific about what we want to get from the data set instead of having to consume the whole thing. But in between, as I was mentioning before, there are some other variants, and this is by no means exhaustive. So there might be cases that I'm missing here. But
Mhm.
there are situations where RDF is embedded, for example, in web pages. That's something that's used for search optimization, search engine optimization. And let me show you some examples. So here's again, I don't know if it's readable, but it's very common in all sorts of newspapers, right? We're going to look at it in a minute. So we're going to look at the source code of the page, and we'll see that it contains a snippet of RDF. And we're going to see what it contains. So
It's in
oh,
the HTML. It's kind of in the
correct,
code hiding, basically.
correct. So it's to some extent dynamically generated, but it's a static snippet. So and you
Right.
can query it, so you just can consume that snippet and see what it contains. It's very common as well in things like art catalogs. I mean, here we have the Louvre museum in France, but many museums do contain this kind of information as well. So normally it appears at the header of the HTML page, and it's not part of what's presented on the browser. So it's meant to be consumed by agents, by robots, by automated processing rather than by humans. So the browser ignores that, but it's interesting, and we're going to have a look at that in a minute. And again, some public pages like the White House or some government pages in many countries again do contain that type of information. So that's another place where you will find
Because
RDF.
it's easier to access for a machine, right? If you want to kind of keep tabs on what's happening in that space. And
Yeah,
things
I
like that.
guess it provide. Why don't we have a look at what this type of information contains, right? So, oops, let me go back to that page. I don't know. Why don't we take the Louvre collection? So let's take that URL. Let's paste it here, and let's look for something. You have a favorite painter? I don't know. There's Monet. That's Claude Monet, hopefully. Bit of a slow. Anyway, so let's take one of the that seems to be not the one that we're looking for. Anyway, that doesn't really matter. So
Right.
we have a catalog item, right? And if I look at the source, so I can do it I can do inspect and find it. So if I do a search here for LD plus JSON, we see that in the header, I don't know, is it readable? Let me make it a bit bigger.
Let's see. Yeah.
So we have a tag here, a script fragment with something that looks like, well, this is JSON-based RDF. So what I'm going to do is I'm going to copy it. Why not?
Mhm.
Let's copy it. And yeah, let's start with the example. Let's take our
That
new.
is basically referencing a script file and
Yeah,
uh,
it's a bit of a summary of the content, right? Because look at,
right.
I mean, if we try to make sense of it, it looks like it has a URL, so of the item. It has a description like Jardin avec des arbres, blah blah blah. So it looks like it's the title of the thing. It has date created. It has the creator. So it seems to have some structured data in there. So how is that meant to be consumed? I don't know. Maybe search engines make sense of this, and we're going to see that, you know, in newspapers you typically have the, I don't know, the title of the article, you know, the section of the newspaper. So it's some kind of schematic data about the resource that maybe will, I know, things like well, I know that the Google Knowledge Graph consumes this information and populates the you know, the knowledge graph with this sort of data. So you have the material, the art form, the height, the width. So there's some pretty rich information. That's why I was thinking we could take these as an example and maybe have a look at it, right?
Yeah.
So let me bring Neo4j. I think I have it running here. I'm going to open the browser, and why not bring it to my where was I? So things have moved a little bit. Let's move things to the right. This is what I was using. So that's my page, and this is my browser. Let's create. Why don't we create an empty database? Going meta, and then is it readable? Or should I make it I don't know if I can make it a bit bigger. Yeah. Good. So that's an empty database. And in
Mhm.
this database, I have already installed both APOC and Neosemantics, which is our kind of interface, our parser that was going to be able to consume RDF for us. And I can test that that's been done by checking the fact that we have N10S procedures. We also have APOC. So they both installed there. So yeah, I mean, in Neosemantics, which is the component that helps us parsing out, in the same way Neo4j natively supports load CSV. So if you have CSV data, there's load CSV instruction that would consume it. So this is an extension that's part of the Neosemantics plugin that will be able to import, or actually preview some RDF data. And every method in Neosemantics has two flavors. So we can have a fetch version or an inline version. So fetch means I'm passing you as parameter a URI, and you go and fetch the RDF from there. Or inline means I'm going to give you as a parameter the actual RDF, which is the case.
Over the line, so to speak. Right.
Exactly. So because I've copied it, I mean, we can have a look at both, but in this case, I'm literally pasting it here. So I'm putting it there, and all I have to do is tell Neosemantics what's the serialization format that I'm using, right? And in this case, we said that it was JSON LD.
Right.
There you go. So that's now if I run this preview instruction, it's not going to like it and it's going to complain. Let's run it, and that's first because it has maybe quotes. That the problem with this is the the scaping. Let's try to see what's up. So it's complaining about Honfleur. Let's try again. Yeah, the problem with this pasting is that if we have yeah, so because you see this is a string, and we use single quotes as delimiter. If we find a single quote inside, it's of course not going to like it.
It's
So
gonna
let's
break
remove
it, right? Make sure that it's uniform and to spec before you put it
That's
in.
right. So that's why it's preferable to use the fetch version. But anyway, so it should still return an error because and again, schema.org. Let's try again. You know what? Let's read it directly from the the fetch, because this escaping is gonna make it horribly complicated. So
Right.
let's do it in 2 steps, because in APOC we have a method called load HTML. So we can load a page,
All right.
and in this case, we're going to pass the page that we're trying to load, which is this one. And then we're going to tell which section we want to extract. So we have to pass, we're going to build something, let's say this is the RDF. And we're going to extract it from passing an expression. And for this, I'm going to use my cheat sheet because I don't know it all by heart. Because it's like, here we go. It's like, so we have to pass head, script, and then application, something like that. So let's.
So you're kind of locating it where on the page it is. And,
Exactly. So it's like, it's kind of a path expression. Let's see if that's what we're after. Hang on. I'm going to use again the single quotes. That's the problem with editing here. But in our page, let's see what it is. So it's a script element inside a div. So inside the body. So it's body, div, script of this type. So that's the pattern. So it has to be a body. Then there's a div, and then there's a script, which is this type. So if I've done it right, hopefully that should return me that particular section. And we've done it right. So you see how it's extracting that particular bit. And it's constructing a map, which I've called the RDF. So
you can do that directly in the database and let the database kind of pull everything that you need in.
Exactly. So what I can do now is say, okay, so this is, I mean, maybe this yields value. And then with this value, what I'm going to do is extract it, because it puts it on a map, and you see it's the RDF and the first value. So I could return value dot the RDF, and I could have called it anything, and I get the first item. So that should get just the RDF. So this is already ready for parsing. So I can pass that now, and I hope I won't have these kind of issues that I was seeing before. So I can say, okay, now I'm going to call my new semantics, and I'm going to say RDF preview, and I'm going to pass inline this.
All right, so you can use APOC to pull it in, and then put it in a value, and then kind of read it in through the RDF.
The JSON-LD. So instead of me copy and pasting, I'm saying, hey, APOC, go to this page, parse the HTML, navigate to this point, body, div, script, extract that element, and then pass it on to the RDF parser. That's what I'm doing here. Now, like I was saying, these yields nodes and relationships, but this is going to complain because I have not created a config. So that's what I should get. Yields.
A config. What do you mean by config?
I'm going to show you just now. So yield is not yields, it's yield. So, can't coerce. Why is it not liking it? So it's not getting a. Was that not a string? So this is value. We saw that was returning a string. Oh no, it was a map. Hang on. We did that here, didn't we? So the RDF. Hang on, there's something not going well here. So let's go. That's the thing with live coding here. So so this is not the RDF starts here. So we probably haven't done it right. So we are going to body div script, and and that type. So it's body div script with this type.
But you,
That's what body div script with this type. And if we do that, what did it return for us? So it was the RDF.
you
Oh,
have the RDF there as a part of.
yeah, exactly. But I wonder why is it not getting? Oh, it's the data part that we are supposed to. Okay, let's try. So if we do that and we get the RDF, we have to actually get the data. Is that it?
Data.
Is the
Oh,
data
so
that
it's probably APOC that is putting some metadata around the
there you
data
go.
returning, right?
Exactly. So that's the actual string
All
containing
right.
the RDF. So let's fix that. And if I run it now, hopefully, there you go. So it's telling me that a graph config is required. And what does it mean? So just to answer your question, Max. So before we're ready to parse RDF, we have to give some basic configuration instructions, right? And let me show you what that means.
Are we
Uh,
talking parsing instructions here? How to form it into a graph, or
Exactly. So
okay,
things like, for example, okay, so like we said before, things in RDF are identified with URIs. Do we want to keep all the vocabulary items, or do we want to ignore them because I don't really need them? So I could do this kind of thing and say, well, you can probably uh, ignore those. You saw before how there were language tags sometimes. Do we want to keep them or do we ignore them? So I can make these kind of choices. What happens when a property has multiple values? Do we want to keep only one and overwrite, or do we want to keep them in an array?
so
So these kind
basically decide how far down the rabbit hole you want to go.
exactly. So I'm going to give this kind of basic config here. So that's the one I'm going to use, and I'm now going to rerun what I was doing before. And there we go. That's a graph, right? So look at what's happening here. So we let's review the code. So we're parsing the page,
Mhm.
extracting the RDF, and
Yeah,
then parsing the RDF and building a graph out of it. So effectively, it's describing a visual artwork. So it's describing the artwork,
yeah, yeah.
and we get the material, we get the name, we get the publisher, we get a URI, and it's linked to a number of things. So we have, for example, height and width. We have a URL, right? So as you can see, there's some interesting nuggets. There's a link to an image, right? So that there's a URL that
Yeah.
I could actually follow, and there's a thumbnail URL, right? So that's the kind of information that this snippet contains. So we see that we have the creator, right? So that would be the author, I suppose. So quite interesting
It kind of
information.
preserves the RDF structure that it already has by
Mhm.
kind of transforming it into a graph that you can query and introspect.
Exactly.
In
Except that here, because we're doing preview, I still
Mhm.
have not persisted it in Neo4j. I'm only kind of
All right.
previewing it here. So these are actual virtual nodes, and you realize that because their IDs are negative, and so our database is still empty. As you can see, there's nothing in our database. There's only the graph config that we've created, but there's no data.
All right.
So yeah, that's well. I just wanted to show how we can, because I want to get back to our deck and see that we could do exactly the same with the Guardian or the New York Times or whatever newspaper, because they all contain, and we could do something similar, and we'll get kind of a snippet of information that we could use to load our data.
Right.
So and same with other sites. So we've had a look at the first one of the cases, right? When we have a fragment of RDF in a page, and we can we can decide to import it, or like we did in this case, just visualize it. So let's say if we're building a knowledge graph, we might want to persist it, and all we would need to do is, instead of preview, we would say import. So if I do that, and again, it's going to complain because the first time we do that, we have to create an index to accelerate the write. So if I do that, it's going to tell me, oops, but of course now this method returns different results, so that yield parse. I believe that's the one of the results. If I do that, no, it doesn't like it. So what's the single method? Let's look at it. So this method returns, what is it? No, that's the preview. We're looking at the import here. Oop. There we go. So it termination status, triples loaded and triples parsed. What did I write? Oh, parsed triples, of course.
No.
So let's return that. And so if I run that now, like I say, it's going to say no because we don't have the index. Let's get the additional info. It's input fetch. Its namespace is called extra info, and what it's gonna explain me.
So why do you need extra info?
You can see it's gonna give me an explanation of why the termination status is KO. It didn't work.
Right.
So it's telling me it didn't work because this constraint is required. So we have to create a unique key on the URI. So let's run that, and that should do it for us. So if I create this constraint, which basically says that resources have a unique identifier, which is the URI. So we cannot have two with the same URI. And once we've done it, if I rerun this input statement, now it's going to say, okay, I've ingested 19 triples. And now if I look at my graph, I will see that I have a persisted visual artwork, the one that we had before, right? And we can expand it now pretty much in the same way we would do with any other data. So now we've kind of persisted some data into the graph from these from this snippet in the HTML data. So good. That's one example. So I was showing how we can explore it visually first and then decide to persist it. But let's quickly have a look at how we would use that different types of data and in what kind of patterns. So the first one is migration, right? So as we described before, if we have a large dump, a data set, we might use it to, as a way of exporting data between triple store to Neo4j. Let's say we have RDF data in a triple store. We want to migrate it to Neo4j so we can export it as RDF and ingest it. That would be an example like the British Library. We can interestingly use it to move data from a Neo4j instance to another Neo4j instance. And I make a note there that, the old logos because it's from an old post. But if you look at this post that I wrote a few months, years ago now, I explain how you can use RDF to serialize data out of a Neo4j instance and import it on another one. So that's an easy way. And again, it shows how I wouldn't go.
In what use case would you want to do something like that?
Well, think of a case where you want to take a portion of your graph or the whole graph and replicate. I mean, if you want to copy the whole graph, then you can do a Neo4j dump and then import it on the other side. That's fine. But let's say you want to import a subgraph. So you have two options. You can write the number of
a big database for all of your data collection, and then you might be working on subgraphs further down your discovery pipeline or whatever you want.
Yeah, but the problem is, how do you serialize a graph? I mean, let's say we have our movie database with actors, with movies, with directors, and let's say you want to just move to another database the actors from the 20th century or from the 21st century.
Right.
So how do you go about that? So maybe you write a Cypher query that gets all the actors from the 21st century. You dump it to a CSV file. Then you do the same with the movies. You put it in another CSV file, and then you write an ingestion.
Kind of tedious, I guess.
Exactly. And because RDF is a way of serializing graph data, I can say, hey, take this graph in Neo4j, this subgraph that I described with a Cypher query, serialize it as RDF, and just import it on the other side. And that's already streamed as graph data, and it's ingested on the other side as graph data. So it's a much more convenient way of moving, fragments of your graph between a database instance.
So
And
you
same would
basically
apply.
make like a subgraph connection between the databases.
Correct.
Wow.
Absolutely. And all the details are in this post, so it's an interesting read. So RDF can be used for data migration. So you take data, you export it as RDF, and you import it on the other side. You can do it in a stream fashion or in a save and then import, but you can do that, like export, import, and that's moving data, migrating data from one side to the other. But we can also use it to enrich a graph, right? So, and we can do it in a materialized or in an on-demand fashion. So we could, for example, and I'm afraid we're not going to have time today, but let's think of the example where I could have my movie database. Let's empty our database, and now it's empty. Hopefully, yeah. So, and I'm going to populate it with my movie database, right? That's the one that comes with J. So we run it, and we have our actors, our directors, and we can now look at, for example, okay, we have Keanu Reeves, and we expand it, and we see the movies that he acted in, and there's other actors in those movies. The Matrix, I can expand it, and we see the rest of actors, including Emil Frem, of course. So, right. So that's the database that we know. Let's say that I want to enrich this model, and I want to do it by querying data from DBpedia. So one thing I could do is, say, take all the nodes of type person from my database, and for each one of them, go do a search in DBpedia or Wikidata, whatever your RDF store,
Some
and
kind of recursive
exactly,
search pattern, right? Yeah.
and get, for example, the place of birth, which I don't have here, right? So
Right.
as a matter of fact, it would be a relatively easy thing to do. Let me show you I won't do the whole step-by-step thing, but you can write a simple Sparkle query. I think we have still the Sparkle endpoint. So this is a simple query that for a given actor by name, Harrison Ford in this case, it's returning me the birth date and the birthplace, right? So it's, if you even if you're not familiar with Sparkle, you kind of see that it's like the triple. So there's something that has a label Harrison Ford, and this something has a birth date, which I alias as birth date, and a birthplace that I alias as birthplace. So if I run that, it will give me the birth date and birthplace of Harrison Ford. So it's very easy to think that I could parameterize this value. So instead of hard coding it for Harrison Ford, I could,
Take
why
the
not?
same structure and
Exactly. Iterate over all the nodes here and issue a Sparkle query to my DBpedia or Wikidata or whatever, and
yeah.
then retrieve that value and maybe persist it as an additional property. And maybe I would have the place of birth or the actual complete date of birth. So that's what I mean by these kind of enrichment patterns. So you can query an external source, an external RDF source, and
All right.
either persist that to enrich your graph, or maybe to produce a combined query result. So let's say I don't want to put it on my database, but I want to return the result combining data that comes from my graph, from my Neo4j graph, with data that comes from a triple store, and put it as a
So you
result.
could have some kind of event triggered thing. As soon as a node comes in of
Something.
this type, you would kind of go off and trying to match that with other data
Sure.
sources. And
You could do that. I mean, either way, in a pull or in a push mode. So that's yeah. I'm kind of conscious of time, but I was thinking of trying to show what that would look like. It looks like we're not going to have time now in this session, but I'll put the code on GitHub as usual,
all right.
and people should be able to see how we can do exactly that, right? Like parameterize this bit here, and then embed that in a Cypher query that does essentially that. It iterates all the elements in our graph, and then query Wikidata, not DBpedia in this case, and enrich the graph. So I'll put that there. And yeah, well, I think I'm gonna stop it here because it took a bit longer than I was planning, but I hope that kind of has given an overview of the different flavors in which we can find RDF data out there and how it can be consumed to enable integration and interoperability with a property graph store like Neo4j. Do we have any questions? I'm going to stop sharing here and go back to.
Right. So we have one thing. Well, we touched a little bit on this earlier about RDF versioning, right? But
Oh, good.
um,
Yeah,
is
that's
there any best practices relating to that, or is there?
Yeah, I mean that's a common tricky problem. I mean, both in property graphs and in RDF graphs. So I mean, probably that's a topic for a future session, because we can look at it from different angles, right?
Mhm.
We've discussed how in RDF we can have schema data like ontologies and instance data. So instance data will naturally evolve and change, and probably makes less sense to keep track of versioning. But master data or schema or reference data is more versionable. And so what I'll do is I'll do some research, and whoever's asked the question, maybe if they have some if they're familiar with any versioning ontologies, we can explore that and maybe make that the topic of a future session, because I think that's a rich
I
topic in
think that
itself,
could be
rather
an
than just
interesting thing, right?
because it's one of these questions that doesn't have a single answer. There's different
Right.
ways to tackle that.
How do you version an API, and how do you?
Exactly. So some will have advantages, some disadvantages. So you really have to pick your poison depending on what's your requirement and what's your need. So yeah, very good one. I'll make a note of it and probably develop it in a bit more detail in a future session.
Sounds good.
So
Sounds
I see that they're asking. They mentioned that Pool Party has a versioning platform, but Pool Party it versions the ontology component. So yeah, absolutely. So that's and some of our customers would do that using just GitHub, right? So that's probably the simplest way. Whether you use Pool Party or Protege or any other ontology development and platform or tool, ultimately your
Then we're
ontology is
talking
going to be
about schema,
schema, correct?
right,
So
and not really.
not instance data, it's schema
Right,
data. But yeah, if you make a schema evolve, probably the simplest way, because your ontology will be serialized as RDF. Nothing
exactly.
stops you from
It's
putting it
change
in
the
GitHub.
schema of the thing that you're trying to describe, and that might be of a different type, right? And
Well, that's the kind of the second level problem. So one thing is your schema changes, but how does that? I mean, and you have to keep track of changes there. But the second question, and that's again another complex one, is how does that affect to your instance data that describe according to that schema? So when the schema change, you have to align your old data with the previous version of the schema, your new data from the new. I mean, so you have to make sure that things are linked together properly. So it's not an easy thing. Versioning ontologies, if you want, is a part of it, and that's probably the easy part of it. But I
right,
think that's definitely worth a dedicated session, because it's a rich topic. And yes, we'll have a look at Pool Party. I don't know if Pool Party offer a kind of an evaluation license or a public version of it, but I'll be happy to have a look at that, and like I say, make a session of it. Yeah.
all
And
right,
yes,
perfect.
we'll share the code in GitHub as usual. So these will go on our YouTube channel, and we'll attach all the code there.
Yeah, and thank you, Jesus, for all your knowledge and sharing what you had for us today. And yeah, I think we're gonna wrap it up there. All right.
Excellent. Well, thanks for stepping in, Max,
Yes.
and see you all in a month. So thanks for your interest.
All right. Bye, everyone.